In today's lesson, we'll be learning how to determine the greatest common factor with prime factorization. If you recall, the greatest common factor is often referred to as the GCF, and a prime number is only divisible by 1 and itself. If you're very strong with your times tables, you will probably be able to determine the greatest common factor intuitively. However, prime factorization is a more systematic approach of determining the greatest common factor. In our first example, we want to find the greatest common factor of 8 and 12. For many students, you'll be able to determine the GCF intuitively. You might come up with the number of 4, and you would be correct. I'm going to show you how to systematically determine this. Let's start with the number 8. We have to think of two numbers when multiplied together that will give you 8. I'm going to think of 2 and 4. Now, 2 is a prime number, therefore we're going to stop there. 4 is not a prime number. Let's think of two numbers when multiplied together will give me 4. 2 multiplied by 2. And these are both prime numbers, so we're going to stop there. Let's go ahead and do the same for 12. Again, think of two numbers when multiplied together will give you 12. I'm going to use 2 and 6. 2 is a prime number, so I'm going to stop here. 6, we want to think of two numbers when multiplied together will give you 6. I'm going to use 2 and 3. Both 2 and 3 are prime numbers, so we're going to stop there. What we've just done is we've found the prime factors of both 8 and 12. Let's summarize our prime factorization below. Eight is equal to 2 multiplied by 2 multiplied by 2, whereas 12 is equal to 2 multiplied by 2 multiplied by 3. When you list out these prime factors, you want to see what's common between these two lists. These 2's are common. These 2's are common. Let's use these numbers to figure out the greatest common factor now. Therefore, the greatest common factor will be equal to 2 multiplied by 2, which is equal to 4. Therefore, the greatest common factor of 8 and 12 is 4. In our second example, we want to find the greatest common factor of 24 and 36. Again, if you're very strong with your times tables, you might intuitively determine the greatest common factor to be 12. Let's double check this with our systematic approach. Let's determine the prime factors of 24 first. We want to think of two numbers when multiplied together will give you 24. I'm going to use 2 times 12. 2 is a prime number. 12 is not a prime number. Therefore, we repeat the process. Two numbers that multiply together to give you 12 is 2 and 6. 2 is a prime number. 6 is not a prime number, so we're going to repeat the process. Two numbers when multiplied together will give me 6 are 2 and 3. 2 is a prime number. 3 is a prime number. Therefore, we can stop. I'm going to use the same process for 36. I want you to think of two numbers when multiplied together will give you 36. I'm going to use 2 multiplied by 18. Now, 2 is a prime number. 18 is not a prime number, so we're going to repeat the process. Two numbers when multiplied together will give me 18. Those two numbers could be 3 and 6. 3 is a prime number. 6 is not a prime number, so we're going to repeat the process. Two numbers when multiplied together will give me 6. Those two numbers are 2 and 3. Those are both prime numbers, therefore we can stop. We've just found the prime factors of both 24 and 36. I'm going to list out the prime factors of both 24 and 36 down below. Therefore, 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3, whereas 36 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. You want to look at both these lists of numbers and you want to see what numbers are common. These 2's are common. These 2's are common. These 3's are common. Therefore, we're going to use these numbers to figure out our greatest common factor. So our greatest common factor is equal to 2 multiplied by 2 multiplied by 3. 2 times 2 times 3 is 12, which matches my prediction. Therefore, the greatest common factor of 24 and 36 is 12. In our third example, we want to find the greatest common factor of 32, 48, and 80. Unlike our previous examples, finding the greatest common factor intuitively of these three numbers can be pretty difficult, and therefore we're going to use our systematic approach instead. We're going to first find the prime factors of 32, 48, and 80. Let's start with 32. What are two numbers when multiplied together give you 32? I can think of 2 and 16. 2 is a prime number, 16 is not, so let's repeat the process. Two numbers when multiplied together will give me 16. I'm going to choose 2 and 8. 2 is a prime number, 8 is not. I'm going to repeat the process once again. Two numbers that when multiplied together will give me 8. I'm going to choose 2 and 4. 2 is a prime number, 4 is not, so I'm going to repeat the process once more. Two numbers which multiply together to give me 4 would be 2 and 2. Again, these are both prime numbers, therefore we can stop. We're going to do the exact same process for 48. What are two numbers when multiplied together will give me 48? I'm going to think of 2 and 24. 2 is a prime number, 24 is not a prime number, so let's continue the process. Two numbers when multiplied together will give me 24. I'm going to think of 2 and 12. 2 is a prime number, 12 is not, so let's continue the process. Two numbers when multiplied together will give me 12. 2 and 6. 2 is a prime number, 6 is not a prime number, so let's repeat the process. Two numbers when multiplied together will give me 6, 2, and 3. Both 2 and 3 are prime numbers, therefore we can stop this process. Let's do this all over again for 80. So we're going to think of two numbers that multiply together to give me 80. I'm going to think of 2 and 40. 2 is a prime number. We're going to stop. Let's repeat the process for 40. Two numbers when multiplied together will give me 40. 2 and 20. 2 is a prime number, 20 is not a prime number, so let's repeat the process. Two numbers when multiplied together will give me 20. I'm going to think of 2 and 10. 2 is a prime number, 10 is not, so let's repeat the process. Two numbers when multiplied together will give me 10. I'm going to think of 2 and 5. Both of these are prime numbers, therefore we can stop this process. And therefore, we found all the prime factors for 32, 48, and 80. Let's summarize all this information down below. 32 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. 48 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. And 80 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 5. We're now going to look for common numbers between these three lists of prime factors. These 2's are common. These 2's are common. These as well. And these 2's are common as well. Therefore, the greatest common factor is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Therefore, the greatest common factor of 32, 48, and 80 is 16.